Welcome to Structural Analysis Lectures by Civil Thinking, and today we are going to see another concept in trusses. Now before I move on, I suggest you to please watch the video lectures on trusses one by one in sequence so that you understand better. The video lectures in sequence are in the playlist. You can find the playlist link in the description, or also you can click on the pop-up on your screen. Now coming to the today's class, today is zero force members in trusses. Now you know trusses have members, right? Trusses have members like this. These are the members, right? This is a member, this is a member. Now when you apply a load, they carry the loads. Okay, when you apply load on the joints, these loads are carried by what? By these members or bars. But somehow there are some members which do not carry any load, okay, which carry no loading or zero loading. Okay, and they, we call them, those who carry zero force, we call them as zero force members. Okay, zero force members. So in a truss we have to find which is a zero force member. Okay, that is the aim of today's class. Okay, so let us find out. Now before we do that, let me read this. The member may be necessarily only for the stability of the structure during construction. Now if a member have zero load, so why we need it? We need it at the time of construction to support, when we construct things have not gained the strength. The beams, the columns, or the members of the truss may have not gained the strength, so we add additional zero force members. Okay, they carry the load at the time of construction, and when the construction is complete, okay, they do not carry any load. Okay, they are called zero force members. Okay, so now in this class we will see how to find the zero force members. Okay, so there are some tricks to find. Okay, and let me show you those tricks. Okay, now we have four rules or four tricks to do. Okay, now this is the trick number one. When you have two members at a joint and there is no support at this point. Okay, when you have only two members, okay, and they are not collinear like this. Okay, they are not collinear, they are not at 180 degrees, they are at other than 180-degree angle. Okay, like this, or maybe like this, whatever. Okay, this is the joint, this is the joint, this is the joint, and this joint does not have any load. Okay, it does not have any load, and it does not also have any joint. Okay, the support or anything. Okay, this is just a joint without any force applied load or any support. Then both of them are zero force members. Okay, and we denote a zero force member with small zero on the members. Okay, when we draw it, it means this is a zero force member and this is a zero force member. Okay, this is rule number one. And the another rule or another trick is, now this was about only two members, right? One member and another member. This is one and two, right? Now let's talk about three members. Now when you have a condition like this, one member, this is joint. Okay, this is one member, this is another member. Okay, now these two are collinear, means they are making an angle of 180 degree, and there is some another member, okay, at any angle, maybe it is perpendicular, okay, or at some angle, whatever it is. When you have three members, two are collinear. Okay, only two of the members are collinear. Okay, two are collinear and another is not. Then, and here is no applied load here, no applied load at the joint, and no support. Okay, no support, no applied load here. Okay, or no support here. When this is the condition, okay, then this member is a zero force member. Okay, this is a zero force member. Okay, now there are another configurations as shown here. When it is in T shape, okay, you see this is T, inverted T, right, or in plus shape, plus, like this. When you are in plus shape and load is only in one, okay, one, this is joint, right? Now this and this, you have load here as shown here, this is the load, right? This is load. and this is 0, you know this is a zero force member. When this is a zero force member, this is also zero force member. Okay, likewise this, now you have joint like this, and here we have no support, and here we have a load like this, or we have a support here. Okay, and this is 0. When this is 0, it is also 0. Okay, provided this is making an angle of 90 degrees. Okay, similarly, when you have this is making an angle of 90 degrees. Okay, the load is only in this side. Okay, and you know this is 0. When this is 0, so this is also 0. Okay, then you have minus shape. Okay, this is like this is a joint. Okay, then if you know this is 0, okay, this is all, it means this is also 0. Okay, now you can remember this trick. Okay, like this, L TV plus minus. Okay, now another concept is this. Okay, L, for example, you have a truss like this. Okay, now you have force in this direction. Okay, now this force and this member, okay, they are collinear, right? They are making an angle of 180 degree, and this one is at an angle of 90 degrees. Okay, this one is at an angle of 90 degrees, then this is also zero force member. Okay, so this was about L. You know, this is L. When you have force, you see this is L shape, right? If you have force like this, okay, it means this is zero force member, L. If you have force like this, or you have a support here, roller support, let me show you here. Because roller support have only one reaction in this direction, right, perpendicular. So when you remove the roller, the reaction is like this, right? It is collinear to this member, right? And this member is making an angle of 90 degrees normal, so this is a zero force member. Okay, this is zero force member. Okay, so this is about L. And T we discussed already, right? When two members are collinear and we have another like this or like this is T, right? But you have to remember, like if it is like this is also T. Okay, and they are collinear and there is no support here or applied load, then this is 0. Okay, this was about T. They are basically, T is about three members, right? Three members at a joint without any applied load or support. Okay, then we have V is about two members, right? Two members which are not making 180 degrees, right? They are not collinear and there is no applied load, right, or a support at this point, then both of them are 0. In case of T, only this is 0, right? Now plus is what? If you have in the plus shape and we have load only in this direction, okay, load W, and you know this is 0, so it is also 0. Okay, minus is this, you have this is a joint and you have two members, collinear member, and you know this is 0. When if this is 0, so this is also 0. Okay, so LTV plus minus, if you remember this, I remember it that way. Maybe you know a different way to remember it. If you know another way, please comment how you remember. Okay, so let us solve some problems on this rule. Now this truss have four zero force members. Okay, let us find how. Now look at this, these two members are collinear, right? This and this. Okay, and this is the another member. Okay, this is three members. Remember the rule, T rule, right? Two members are collinear and another is there, another member, and there is no support here, so this is a zero force member, right? So I can just remove this member. Okay, so this is a zero force member, right? Now let's come to this. Now you look at this, this is one member, this is another member, they are collinear, and it is again T, right? So this is again zero force member, so I will remove this. Okay, so this is zero force member. Now again, if you look at this is one member, this is another member, this is again the T case, right? This is zero force member, so this is zero force member, right? So this is zero force member. Now look at this again, the T, right? One member, another member, they are collinear, and another is like here, right? So this is another zero force member, right? Now that's it. Now these members carry forces. Let us check them. You see, is there any L shape? There is, yes. The L, you know, L TV plus minus is the rule, right? Now L is about what? L is about when there is a load, right? Now this is pin, you have a load here and you have a load here. Okay, in L you have load in only one direction. Okay, if this is in this direction, this is 0, or if it is in this direction, so this is 0. Okay, so L, similarly here is no T condition, here is no V, if it was no load here, similarly here is no plus or minus condition. So how many zeros, zero force members are here? 1, 2, 3 and 4. Okay, 4 zero force members. Okay, now let's try this. You can pause the video and try and see if you get 5 zero force members. Okay, now let us do it. Now you see the rule is LTV plus minus. Okay, now you see this is T, right? This is these two members, they are collinear, and this is another side, so this is zero force member, right? So I will remove this. Okay, now you see this is V, right? V rule, there is no applied load or external support at the joint, so these are both 0, right? This is 0 and this is 0, so I will erase them. Okay, when you erase, you get, you understand, okay, more things. Now what is this? Now this is L, right? This is L shape, you see L. Okay, L can be like this or the mirror image. Okay, you have load in this direction, and this is at this side is at an angle of 90 degrees, right? So we have, this is zero force member. Okay, so this is zero force member, right? Now let us see if we have more zero force members. Now look at this, this is L shape, right? This is L shape, and in a roller support, how do you have support? In roller support, the reaction is like what? The reaction in a roller support is like this, right? And you see this is again L. Okay, so 0 is here, right? So the load is in this direction, so this is a zero force member. Okay, so I will erase this also, right? So this is a zero force member. Okay, now we do not have any condition, any more condition. Okay, so 1, 2, 3, 4, 5, we have 5 zero force members. Okay, I hope you get the idea. So let's move on. Let's talk about this. Remember the rule LTV plus minus. Okay, now look at this. These two are collinear, and this is another side, so this is T here, so this is 0, right? This is 0. Okay, now let's see more. Yes, we have here T again. These two are collinear, right? And this is other side of T. Okay, so this is also zero force member, right? This is also zero force member. Let me erase this. Now look at this. This is one member, this is another member, they are linear, again the T condition, and this is, right, another side of the T. Okay, so this is zero force member again, right? This is zero force member. Now Look at this. This is again the T. This is one another. Okay, they are collinear, and this is, we have no load here. Okay, this is zero force member, right? So this is also zero force member, right? Now let's see this. Now see this. This is collinear. This is collinear, right? And you have no external load or support. So this is a zero force member, right? This is a zero force member. Now look at this. This is linear, and this is linear, and this is other side of T. So this is zero force member, right? So I will erase the zero force member, right? Now look at this. This and this, they are linear, and here this is other side of T. So this is zero. Okay. Now look at this. This is one side of T. This is another side of T, and this is, these two are collinear, and this is the other side, right? So this has to be zero, right? So this is also zero, right? Now there is no another condition, I think. Let me count: 1 2 3 4 5 6 7 8. So you have 8 zero force members. Okay, so this is how you find the zero force members. Okay, just remember this rule: L TV plus minus. Okay, L can be like this too. Okay, the mirror image. Okay, so that's it. This is how you find the zero force members. If you have any doubt, please comment, and please tell me in the comments, how do you remember? I remember it like this: LTV plus minus. And how do you remember? Please tell me. Okay, so that's it for today. See you in the next class. Thank you.